Hello, and welcome to Naraxon's MR3 shoulder measurement tutorial. In this video, we will cover the basics of how to effectively measure motions of the shoulder, beginning with what sensors are necessary and sensor placement and considerations. Then, we will move on to discussions of what shoulder flexion, abduction, total flexion, and shoulder rotation represent in our anatomical model, and the measurement considerations for these angles. To obtain the shoulder joint angles that MR3 provides, you will only need the upper thoracic and upper arm sensors for each arm. In general, the most critical details to consider when placing sensors are 1. Sensor placement, 2. Soft tissue artifact, and 3. The bilateral symmetry of the sensors themselves. It is recommended to place the upper thoracic sensor at C7, fastened to the skin using double-sided tape. The sensor can be further stabilized using physiotape or similar adhesives. This placement, however, is susceptible to soft tissue artifact depending on the subject and extent of the motions being characterized. Soft tissue artifact can be better visualized by attaching a thin item that is as straight as possible to the sensor, as shown on the subject here. If C7 placement is not suitable for your applications, an alternative placement is on the sternum, making sure that the sensor face is towards the body and is as close to 90 degrees vertical as possible. The arm sensors should be placed at the lateral edge of each arm in such a way that they are not susceptible to tricep muscle bellying and as close to the midline of the lateral side of the arm as possible. For bilateral measurements, make sure that the arm sensors are as symmetrical as possible in the axial and sagittal planes. Shoulder flexion is measured using a projection angle in the sagittal plane and is defined between -90 and 270 degrees. The arm in line with the body is measured as 0 degrees of flexion. The arm flexed in front of the body, such that the hand is parallel with the shoulder, is 90 degrees. And the arm flexed such that the shoulder is parallel with the ear should measure at 180 degrees. Shoulder abduction is measured as a projection angle in the frontal plane, and is defined between -90 and 270 degrees. The arm in line with the body in the coronal plane is measured as 0 degrees. The arm abducted to the side of the body such that the hand is parallel to the shoulder is 90 degrees. And the arm abducted such that the shoulder is parallel with the ear is measured as 180 degrees. Shoulder total flexion is measured as the angle between the arm and the body in any position between the coronal and sagittal planes. Note how total flexion does not change as we rotate between 90-degree abduction and 90-degree flexion. Shoulder rotation is measured as the rotation of the arm in the axial plane and begins at -45 degrees. Any rotation towards the subject's back is positive rotation, and any movement towards the subject's chest is negative rotation. This will remain true for any orientation of the arm. Shoulder measurements can be deceiving. For example, here we see a subject abducting to 180 degrees and what looks like should be 180 degrees of flexion. And while abduction measurements show 180 degrees, flexion shows 160. It's easy to think at first that something may be wrong. However, upon inspection, we can see that flexion really is around 160 degrees. Barring problems of soft tissue artifact or poor sensor placement, it is generally safe to assume that the sensors are really showing you what's happening on your subject. Similarly, due to the measurement range of both abduction and flexion and the sensitivity of the sensors, we must be very careful when interpreting the data at 90 degrees of either movement. For example, When we have 90 degrees of abduction, we create a very small window for flexion to be anywhere between 270 and negative 90 degrees, depending on small shifts within this circular window here. And so in this example, the sensor is shifted slightly backwards, measuring 266 degrees from 0. The same phenomenon can occur at 90 degrees of flexion. Here, abduction measures 92 degrees because of the same principle just discussed. Thank you for watching our shoulder measurements tutorial. If your questions were not addressed in this video, please contact your sales representative or send an email to support@noraxon.com.